Hello there. It's exciting to have you here today. I am Aishwarya and I will be taking you through an interesting topic to explore today, which is going to be on sundials. Okay, so what exactly are we going to be discussing about sundial today? I will be taking you through a few topics, which is going to be number one, a brief history about how sundials used to be one of the most renowned timepieces in those ancient days. And then I will explain to you what exactly a sundial is and how does it work, or the mechanism of a sundial. And finally, we will see how can we make and use our own mini sundial right from our homes. So hopefully this is as exciting as it is for me, for you as well. And let's move to our first section for today, which is going to be on the history of sundials.
Sundials, also known as sun clocks, was first discovered in the skirts of ancient Egyptian and Roman civilizations, dating more than 3,000 years ago. But don't let those numbers fool you. These civilizations have been so geometrically inept, their sundials told more than just the passing hours of the day. In a series of concentric circles and curbstones, they showed weeks, months, and even years. The Romans even laid a giant, heavy vertical stone called an obelisk in their cities, differentiating the summer and the winter solstices, being some of the earliest markers of Earth's seasons. The ancient Egyptians and Romans weren't the only ones using a sundial. Many medieval and Asian civilizations also hopped along the wagon, infusing their own understandings of astronomy and their cultures alike, perfecting the crafting and precision of sundials, enough to be made in portable pocket sizes, just as how we carry watches these days. Since sundials can only be utilized during the daytime, the concept even gave birth to moon dials to be used at night. However, due to the ever-changing phases of the moon, it wasn't as popular as its solar counterpart. Sundials stayed even in the earliest clocks were made as a form of reference to ensure the clocks are running accurately.
Okay, so how exactly does a sundial work? A sundial is an instrument that could tell us about the position of the sun in the sky from sunrise all the way until sunset. Well, technically the sun doesn't move. It's a fixed star in the sky. The Earth, on the other hand, will rotate on its axis. And due to this rotational factor, the horizons or the skies of the Earth would actually change directions on a rotational basis as well. And this would cause an apparent motion to be present to the sun. So we would see the sun to be moving instead when we view it from the Earth. And just as how light rays would work when sunlight hits the Earth, if it's blocked by an opaque object, it would cast a shadow on the opposite side of where the rays are hitting the object. So the sundial works in a similar way. We take an opaque object, so in this case, it's a long vertical rod called the gnomon, to be placed on the ground facing north. This, when faced north, could give us a distinction between the eastern and the western side of the sky from sunrise to sunset. And as the sun casts its rays on this opaque object or the gnomon, it will cast a shadow on the other side. And considering this whole scenario to be circular as the Earth rotates around its axis, the whole movement of shadow around this vertical rod or the gnomon is also going to be circular. And that's how we would be able to use it as a clock, as the direction of the movement is going to be same throughout the days. And it also follows a certain pattern as the sun would rise and set on the same direction every day. So that's how we use the sundial to actually get the timing for the day as the day passes.
Do you want to know how to craft and use your own mini sundial right at your home? I'll show you how. You'll need a party plate to be the sundial's base and a wooden pencil to be the sundial's shadow caster, vertical rod, or the gnomon. You can use a ruler to mark your center point to fix the gnomon and a little marker to aid you with crafting the hours. I also used a protractor to help me evenly divide the circle into 12 hours to make it more clock-like. And fret not, your sundial's entire anatomy can be found in the ringgit store to be bought. Once the base has been set, I poked a little hole at the center point with a scissors to set up the pencil, aka my gnomon. And I also wanted to give my sundial a more sturdy base, so I sealed the pointy tip of the pencil below the party plate with a small polystyrene block. That's pretty much that is there. And for my sundial, I emphasize mostly on the precision of the center point as well as the hour marker. But if you seek to add a little dose of creativity, you can always add colored tapes, markers, or highlighters around your sundial, and this step is entirely optional to you.
So here it is, my end product, my mini sundial. So you can see the numbers in here. So I've labeled the hours marked in a circle, and I fixed this pencil to be gnomon in the center point of the sundial. And at the back, I have actually inserted this polystyrene block to stabilize the whole thing, so that, you see, if we look closer, this dark tip here is supposedly the pointy tip of the pencil. So if we were to place this polystyrene block, it won't really wobble a lot when we place the sundial on the ground to take the reading later. So it's more sturdy and it stands still. And now it's 9:44, and my place is a bit cloudy these days, so I think I would need to wait a little longer before I would actually take the sundial out, so the sun shines with the right amount of intensity to give me the crystal clear shadow for my sundial later on. So here am I in the front of my house near the porch area, and the sun has started to shine brightly. There is enough sunlight for shadows, and now it's about 10:10 in the morning. So before I place my sundial, I'm actually going to adjust my measuring location to be facing the exact north. So I'm going to use this compass that's there on my phone to first adjust the location slowly so that I'm standing facing the exact north to give me the most accurate reading with the sundial. So yeah, so now it's set at 0 degrees north, and after this I will be placing my sundial, and I will be taking the reading once every 1 hour. made the comparison from the readings I've obtained from my sundial through both interval series, I found out that the readings were near similar to one another, meaning that the shadows casted on the sundial for both days during that particular hour is almost similar to one another. However, I also discovered a startling observation. That is, during certain hours, I observed that the shadow casted on my sundial is actually lagging in comparison to the time that has been shown on the clock that I used as a reference point. And I also deduced that this usually happens between the hours of 11 a.m. and 1 p.m. more frequently. So I wanted to know what exactly is happening, as in, is there a lack of precision to my sundial, or it's really an astronomical phenomenon taking place. So that's when I read back on the mechanism of a sundial. So as we discussed earlier, sundial typically shows us the position of the sun in the sky on a particular moment that we are taking the reading on. Hence, it is completely independent of any measures of time that we have on a clock, for instance, and it purely bases on the position of the sun during that particular day based on the area that we are taking the reading from on the horizon, on the sky. The clocks, on the other hand, has a total different concept. It's a mathematically curated device. Hence, it looks at the accuracy of the hourly count. If it's 12 p.m. today, it would need an exact 24 hours before it shows 12 p.m. again on the next day. And it doesn't take into account the variation of sunrise or sunset on any different days. As long as the hourly cycle is complete within a clock, it would keep moving. The sundial, on the other hand, is very much dependent on the positioning of the sun based on the sunrise, the sunset, the longitudinal effect on where the sun would be rising and setting on the sky when it comes to giving the reading. And when we put these two comparisons together, we can clearly deduce why there was a certain delay, especially during the midday, because the midday on the sundial comes in when the sun is exactly at the middle of the horizon in whichever location that I'm taking the reading on. And until that has been reached, it's still not going to be midday in the sundial. However, on the clock, it's still going on an hourly completion basis. If 60 minutes has passed after it last showed 11 a.m., it's still going to show it's 12 a.m., independent of whether the sun has reached the middle portion of the horizon or not.